everyone. Welcome back to LABrary. I'm Miss Kathleen. Thanks so much for joining us today. We are going to do part 2 of our program on popcorn today. So last week I issued you a challenge. But first of all, let's just review a little bit of what we talked about last week. We talked about that there were 2 different kinds of popcorn. Do you remember what they were called? We have butterfly popcorn, that's the fluffy kind with the expanded wings. And then there's mushroom popcorn, and that's fluffy, but it's rounded and more compact. And the butterfly popcorn is used for popcorn, like movie theater popcorn, microwave popcorn, any popcorn that you would eat, like in single puff pieces. And then the other one, the mushroom popcorn, is used to make caramel corn and caramel corn balls. But you can use whichever popcorn you want at home if you wanted to make caramel corn. I have a really great recipe for you coming up later. I'm excited to make it. So we talked about that corn is a human invention as we eat it now. Popcorn is a little different in that it has to be dried first, doesn't it? So that was part of what I wanted you to find out when you did your research. So, how and why does popcorn pop? Well, each little kernel of popcorn contains a tiny amount of water, doesn't it? Did you learn that? So what do we know what happens with water when it heats up? It becomes a vapor, doesn't it? And it has to get out somehow. So the vapor that's contained within the kernel expands, and as it expands, it pushes against the hard outer starch of the kernel's outer layer, and then it explodes. And the soft starch inside the popcorn becomes inflated and bursts. And then the popcorn kernel turns inside out. So this is what it looks like. It starts with just the little compact kernel. And then it starts to heat up, then it pops a little bit, and then it expands all the way. So I don't know if you learned this in your research, but I had fun researching how much Americans love popcorn. We really love it. We eat, as a nation, 4 billion quarts of popped popcorn each year. The average American eats 43 quarts. That is so much popcorn, isn't it? So here is an old picture from the 1900s of this really cool harvester, and it's harvesting the popcorn. So the popcorn has to be dried. Well, the outside, the husk part is going to be green as it grows, just like our regular corn that we eat here. That's table corn, corn on the cob. And so farmers leave it on the stalk until the husks, the outside part, become papery and white, and then it's picked. And then, say you're a home gardener, you could tie it in bundles like they have in this picture here, or if it's commercial corn, then it's hung in these wire mesh baskets and then dried out for a period of weeks. And it's really important, from what I read, to harvest it at just the right time. You want to harvest it before the first frost and definitely before it rains, because you don't want the popcorn to get wet at all, because it's going to need to dry out. So I found that there was this really beautiful variety that home gardeners can order as seeds, and it's called glass gem popcorn. There's all different varieties that are really pretty, but I thought this one was beautiful and I wanted to show it to you. It says this corn was bred from a number of native varieties by Carl White Eagle Barnes, a famous Cherokee corn collector. I didn't know there were corn collectors, but I thought that was really cool. So here are a couple of more popcorn fact links for you. So there's one in particular that shows you, if you're going to be a gardener, a home gardener, how to harvest your popcorn and how to dry it. And then the other link tells you just more about popcorn's history. So it's ancient history and it's more recent history, and just some fun facts. Okay, remember I told you that I had a really great recipe to share with you? Well, first of all, I want to show you that I popped my popcorn. It smells amazing in here. Once again, I wish we had smell-o-vision, but this is the popcorn that I put salt on after it came out of my bag. That was rude. I shouldn't eat in front of you. Sorry. Okay. This is the popcorn that came out of my brown paper bag that I put a little bit of oil in. I don't know if you remember, but last week I told you that you could just use a plain brown like lunch bag and fold it over once after you've put a 1/4 cup of unpopped popcorn in it and a teaspoon or 2 of vegetable oil, not olive oil. And then mine took about 3 minutes to cook. And when you want to take it out is when the popping slows down. And you may already know this from popping regular microwave, commercial microwave popcorn. Okay, so the popcorn recipe that I have for you calls for 14 cups of popcorn. That's a lot, but actually this is probably like 3 cups right here, 3 or 4 cups. And then it's a gingerbread caramel popcorn. So it has like gingerbread spices in it. And here's a picture of it. Doesn't that look delicious? Okay, thank you so much for joining me today. I am really excited to see you next time for LABrary. And next up is Mr. Travis with a new program for you. Okay, we'll talk to you later. Bye-bye.
Hello, my fellow librarians. Mr. Travis here. Time for another LABrary, and today we're going to do an experiment. We're going to do a challenge, and it's not going to take many things to get this accomplished. We only have 2 things we need to gather today. We need some paper, and we need some tape, just like some, clear plastic tape. Those are the only 2 things. And what we're going to do, we're going to show off the power of paper, how strong we can make something paper. So basically, the only other thing you're going to need to find is something heavy. Because what you're going to do is you're going to take this paper and tape and you're going to figure out how to make something that will hold something heavy. So, I'll give you a couple of hints on what to do, because you don't necessarily think of paper as something being strong, but it can be if you put it into the right shape. So try first rolling up the paper, rolling it up, and make a little column out of the paper and test that. I'll give you a hint. It's going to make it much stronger. And then there's other shapes that you can try that will make it even stronger. So if you look at different things in engineering, bridges, say, just look at things that we've made and see if you can notice like what's going on, what kind of things and what kind of shapes are used often when we're constructing things. So like on a bridge, you'll see columns, which would be like rolling up our paper, but you'll also see, a lot of times you'll see one particular shape, you'll see triangles. Triangles are one of the strongest shapes because when you apply pressure to one of the points, it actually distributes the weight all through the triangle. So it adds stability, that makes it so things don't wobble. So, test with rolling up paper, test with triangles, test with other shapes. And so, in order to accomplish this and go through our STEAM challenge, STEAM stands for, it's an acronym, it stands for science, tech or technology, engineering, arts, and mathematics. So for our S portion of it, our S portion of this STEAM on the science, do you know what force is that your structure has to overcome? What force is making something heavy? What's the name of that force? I think you know. And then the T for technology says, can you make different structures? Can you make something that'll hold heavy weights that look different, or as you test the technology, see if you can improve it. E for engineering, look at some other things that we use or we build and see if you can discover some of their secrets. Like looking at bridges especially. This has a lot very similar to building a bridge. A is for arts, and could you do something with your structure, like make a big make a big skyscraper that you'd want to put a tall statue on, and how would you hold up that structure, and could you use the same principles you want to something tall and thin to hold something tall? And then finally, M, this mathematics. And for this, think about how strong, to test how strong your shape is, to your design is, let's weigh it. So what you'll do is before you put anything on your structure, you'll weigh it. You can use like just a regular like bathroom scale or a kitchen scale. You'll write down how much it weighs, put it on there, and then if you want to test it even more, you can add something to it. So you get another thing, weigh that, put that on top, and if you add the two, and then you'll get the total weight. And if as you put on more, just add them up, and you'll get how much your structure can hold. So next week I'll show you kind of what I built, and if you want to share anything, please just send it to me here at travis@mld.org. And I promise if you send it to me, I will share it. We'll look at it on our next video next week. And yeah, that's it. So have fun with this. We'll see you next week.